Today we will see the worked out example of Griffith third edition Introduction to Quantum Mechanics. The example 2.2 is a particle in an infinite square well has initial wave function psi of x and 0 is equal to a multiplied by x into a minus x between the limits 0 to a. A is the box length. For some constant a, as shown in the figure, this is the initial wave function. Outside the well, naturally the psi equal to 0. Then our task is to find the wave function, time dependent wave function, that is psi of x and t. Now to find the normalization constant, psi star psi integral over psi star psi tx is equal to 1. So now psi star psi is equal to a square x square a minus x whole square. So now if you take psi star psi, which is equal to, of course you take a square x square, here a square plus b square minus 2ab. So if you multiply this with the x squared, first term a squared x squared, second one x power 4, third one is 2a x power 3. If you solve this, you will get, this is a very simple and useful way of calculating it. A squared a power 5 divided by 30 is equal to 1. That means a squared is equal to 30 divided by a power 5, or a is equal to square root of 30 divided by square root of a5. So we have found this normalization constant. Then we will find the time dependent wave function. In order to find the time dependent wave function, we are using Fourier techniques here. Psi of x and t is equal to summation over n Cn psi n of x e power minus I en t over h cross, where Cn is equal to integral between minus infinite to plus infinite psi of x and 0, that is initial wave function, psi of x tx. This is nothing but in Dirac notation. This is inner product of initial wave function and wave function, total wave function psi of x. So this psi of x is I have given in the yellow color bond, that is square root of 2 pi a sin n pi by a x. This is for infinite square well potential. Then this initial wave function psi of x 0 is equal to square root of 30 divided by a power 5 x a minus x. So we have to integrate it between the limit 0 to a with respect to x. So this integral can be separated into two forms. First ax, this sign term. I can take out because it's a constant. X sin n by ax tx. Next one is here you have minus. Minus x into x, you will get x squared sin n by ax tx. Now we have two integral. We have to calculate these two. First one is this one, including this a. This is, I am labeling it as I1 and this is I2. So here you can see this is square root of 30, this is square root of 2, which will become square root of 60. And here a power 5, square root of a power 5, here square root of a, which will become square root of a power 6, which is, if you remove the square root, this will become a cube. So the Cn is equal to square root of 60 divided by a cube I1 minus I2. Now we will find the integral, each integral value. Now we will do the first part of the integral. using integral by parts. Let us take x is u and sin n by ax is dv. So u dv is equal to uv minus integral v du. Of course, we have to multiply this integral by a. So I am taking a outside. So then x is equal to first uv. U is x and v is minus a by a divided by n pi cos n by a x. So if you differentiate this, you will get back sin n by a x. So this is v actually. So u is x v. Now you apply this limit, that is 0 to a. So what will happen for upper limit? This upper limit is a. So this a will get cancelled, which will become cos n pi. Here one x is there. So this also will become a. This x also a. So a into a squared, already one a outside. So this will become minus a cube divided by n pi cos n pi. Then what about this one? So you forgot about multiplicative constant. Here v is this one, this terms inside bracket. Tu is actually tx only because we have taken u as x. Naturally, tu is equal to tx. So you forgot all the multiplicative factor. If you integrate this cos x, you will get sin x. When you apply the upper limit, a will get cancelled. You will get sin n pi. Sin n pi is 0. Naturally, sin 0 also 0. So this will be always 0. So you will get only the non-zero value for upper limit of the first term, which is I1 is equal to minus a cube divided by n pi cos n pi. Then we will move on to next integration. Now integral I2 is integral between 0 to a x squared sin n by a x dx. Here also you do the integral by parts. Here you can keep x squared as u. This sin term is dv. Then v is, we have seen in the first case, it is v is equal to minus a divided by n pi cos n by a x. So if you differentiate this, you will get back this sin term, sin n by a x. So here u is x squared. Then what is du? U is equal to x squared. Then du is equal to 2x dx. So I am going to replace v. We know this yellow color, the terms inside the bracket. I am taking as it is. A divided by n by cos n by a x dx. Now what is v? We have taken as it is. What is du? Du is 2x dx. So 2x dx. I have replaced the u also, du also. Now, as we have seen in the first case, if you apply the limit 0 to a to 0, maximum limit is a, upper limit is a, lower limit is 0. When lower limit is 0, this x will be 0, so you need not worry about the lower limit. For upper limit, this will get changed. A will get cancelled. You will get cos n pi, and x square also you have to replace. This you can take as a square. Already one a is here. So it will become minus a cube divided by n pi cos n pi. Then the next one, you bring this minus outside. So this will become plus 2 and a divided by n pi, because this is constant. I am taking out this also. Then this will be x cos n pi by a x dx. Then we have to take care of this second part of the integral. Now we have done the integration part, the first part. The second part, we have to do the integration by parts again. Here, let us say x is equal to u and cos n by a is dv. So apply the u dv is equal to v minus v du. So here I am taking 2a divided by n pi as a common thing, common factor. Then u v, x is u and a divided by dv is, this is v. If you differentiate this v, you will get back this one. So uv, here you have to apply this limit 0 to a. 0 to a. So when x is equal to a, this will become n pi. A will get cancelled. Sin n pi equal to 0. If you apply lower limit, sin 0 also 0. Here one x is there. So it will be always 0. This will be always 0. Then take the next case, minus v du. Here v is a divided by n pi sin n pi by a x dx. Because du is, we have taken x is as u, then du is u is dx. So no problem, we got this one. Then if you integrate this, you will get this a divided by n pi. Already here there is 2a. 2a into a will become a square. If you multiply this and this, you will get 2a square divided by n pi whole square. Then if you integrate sin x, you will get cos n pi by ax divided by pi by a, which is equal to again 1a divided by pi will come, n pi will come. So which can be written as 2 times a cube divided by n pi cube. So I have taken this 2a cube divided by n pi whole power cube. Here you have to apply the limit 0 to a. For upper limit, if you apply a will get cancelled. You will get cos n pi. If you apply lower limit, cos 0 is 1. So you will get minus 1. This is I2. So now we will see the value of Cn. Now we have to find the value of expansion coefficient, that is Cn, which is equal to square root of 60 divided by a cube I1 minus I2. Here 60 can be written as 2 square root of 15 and of course divided by a cube. Then I1 is this value minus a cube divided by n pi cos n pi. Then I2 is equal to minus a cube divided by n pi cos n pi plus 2a cube divided by n by q cos n pi minus 1. We have seen just now. Then here compare first term of this, first term this. So we are subtracting both the term. Then this will get cancelled with this term. Then only terms left out is last one. That is minus, here you have minus 2a cube divided by n by q cos n pi minus 1. So if cos n pi is, n is even, this will become 1, 1 minus 1, 0. So Cn will be 0 if n is even. What will happen if n is add? Then this will be cos will be minus 1. Minus of minus 1 minus 1 is minus 2. So this 2 to minus 2 multiplied by this 2. Minus of minus will become plus. 2 into 2, 4. Already one 2 is here. So this will become 8 square root of 15, and this here AQ will get cancelled, so only terms left is n by whole power 3 if n is add, because if n is add, this term will become minus 1, minus 2. If n is 0, this will be, sorry, n is even, this will be 1 minus 1, this will be 0. So this is the expansion coefficient. Now the time dependent wave function psi of x and t is equal to, using Fourier techniques, summation over n Cn psi n of x e power I En and t over h cross. So now we know the Cn exists, Cn is non-zero only for add integer, that is n equal to 1, 3, 5, and Cn value is just now we have seen 8 square root of 15 n pi whole power 3, and this psi n wave function is square root of 2 divided by a sine n pi by a x, which I have shown in yellow color. This psi n x I have shown in the yellow color part. Then e power minus I e n t over h cross. Now we can simplify some of the terms. You can see this 15 square root of 15 into square root of 2 will become square root of 30, and here you have square root of a. This also we have taken. So this will become 15 into 2, 30 divided by a square root of course. Then here you have 8. 8 can be written as 2 power 3. So already there is one pi power 3 is there. So 2 divided by pi whole power 3 you can write. You cannot keep n outside because it's a running index. So you can bring this n inside, which will become 1 over n cube. This sine n by a x e power en of t over h cross can be written as en by h cross. You know, for infinite square well potential, en is equal to n squared pi squared h cross squared divided by 2ma square. You bring one h cross to the left hand side. Then En over h cross is n squared pi squared h cross over 2ma square. I am replacing En over h cross. This En over h cross pi this term. That is n squared pi squared h cross over 2ma squared. Of course, you have t. Why I am doing this is you have n, running index is n. So this is the time dependent wave function. Thank you very much for watching my video and supporting me continuously. Thank you very much.